Even, odd, neither functions. What are they?
Easy.
What's it all about? It's easy to add them.
Oh.
So here's the deal. We know a very obvious odd function, even function rather, is y equals x squared. Let's take a look at y equals x squared. There's y equals x squared. What characteristics does it have? The first characteristic is that f of negative x equals f of x, which means if I plug negative x in to it, I get the same thing as f of x back out of it. That's one thing. That's one relationship that is true. And another relationship that's true is you'll notice that it's symmetric to the y-axis. Here's your y-axis, and if I flip it over the y-axis, I'll get back to itself. So it's symmetric to the y-axis. So if you have a picture, and by the way, if you have a graph and you can tell by the graph that it's symmetric to the y-axis, then it's an even function. So let's talk about another classic even function would be the function cosine of x. Cosine of x. Notice if I flip it over the y-axis, I'm going to get back to itself, which means what about cosine of negative x?
Same.
It's the same as the cosine of x, which is true if you look at the unit circle, or if you just punch it in your calculator, you'll see that that's true. All right, what about odd functions? Odd functions, the classic odd function is x cubed, right? Y equals x cubed. And what do you notice about y equals x cubed? Well, first of all, if I plug in negative x, what do I get out? Let's try it. Negative x cubed is what? Negative x cubed. What's the difference between these two things? They look the same, but they're different.
One's positive, one's...
Yeah. One is negative f of x, and the other one is f of negative x.
Oh.
So if you can show that f of negative x is equal to negative f of x, then that means it's an odd function. So this is characteristics of an odd function. The other thing you can notice about this is if you flip it over the y-axis and then the x-axis, which is called symmetry to the origin. If it's symmetric to the origin, then it's an odd function. Some people say, well, why isn't it symmetric to the x-axis? Well, it can't really be symmetric to the x-axis because then it would be not a function. Like it's something that's symmetric to the x-axis would be a sideways parabola.
Yeah.
But that's not a function.
Okay.
So not happening. So let's talk about a classic odd function. Well, you guessed it. What's the next thing besides a cosine? Sine. If I flip the sine function over the y-axis and then over the x-axis, I'll get back to itself. So the sine of negative x is equal to negative sine of x, which is another one of the properties that you learn in trigonometry. So that's even and odd functions. One other quick thing about even and odd functions, if you have x cubed plus 3x minus 1, if that's your function, or if you have y equals x to the fourth plus 3x squared minus 1, this one is neither, and this one is even. The reason is because if you imagine plugging in a negative x into here for everything, plug in negative x into here and here, these signs will change, but this sign won't change. So f of negative x does not equal negative f of x. Whoops. But for this one, if you plug in negative x, this sign won't change, this sign won't change, and this sign won't change. So f of negative x does equal f of x. So one way you can tell if it's even or odd or neither, if it's a polynomial function, is look at the exponents. Now what happens if I had y to the fourth, y equals x to the fourth plus 3x to the third minus 1. Is that even, odd, or neither?
Neither.
That's obviously neither because there's an even and an odd exponent. And so neither one of these two things that you're looking for would be true.
I have a question.
So let me clarify a little bit more about what I'm saying here. What if I had y equals x cubed plus 3x? Even, odd, or neither? That's odd. Because all of the exponents are odd. So here's the quick little summary. If all of the exponents are odd, it's an odd function. If it's a polynomial function where all the exponents are odd, it's an odd function. If it's a polynomial where all the functions are even and it can or doesn't need to have a constant, it's even. But if all the exponents are odd, but you have a constant term, then it's not odd. That's what I'm trying to say.
So that minus
That
1.
is neither.
Yeah.
But so x to the 13th plus 5x to the 7th minus 6x to the 5th plus 3x, even, odd, or neither?
Odd.
That's odd because all the exponents are odd. But what if I add minus 1 or plus 1 or something?
Neither.
Then it's neither. But if all of these are even, x to the 14th plus 3x to the 8th minus 7x to the 2nd, as long as they're all even, is that even, odd, or neither?
Even.
That's even, but what if I add plus 2?
Neither.
It's still even.
What?
Yeah, that's what I was trying to get at with this explanation up here. If it's an even function, it doesn't matter if you add another thing on there because you're still going to have this relationship. F of negative x is still going to equal f of x. And if you think about what that does, adding something to, here's another way to think about that. Adding a number to this, does it change its symmetry?
No, it still is.
No, it's still symmetric to the y-axis. But if you add a number to this, does it change
Yeah.
its symmetry? It does, because now you move this up, and even though it's symmetric now, if you flip this graph over the y-axis, it would be down here. If you flipped it over the x-axis, y-axis, which is not the same thing. Another way to think about it.